Okay, so the projectiles part B, so the inclined plane one, inclined at 30 degrees to the horizontal, also projected at 30 degrees as well. Kind of simplifies things in the equations because you don't have to worry which is which. Initial speed at angle 30, range along the flying plane is D. D in terms of U, that's fairly straightforward, just the range in terms of D. This one bounces vertically upwards and the coefficient of restitution between the inclined plane is E. Find the value of E. So if it bounces upwards, so that's just, and you just have to think about those ones, like the other one is striking the plane horizontally, stuff like that. But so if it's bouncing vertically upwards, then now, so you have to remember that we are inclining the x-axis along the plane, that's the way we do it, and the y-axis then is perpendicular to that. So that's your projectile. It's gone down like that, so it's U and 30 degrees there and 30 degrees there as well. So if it's going vertically, then relative to the plane, if you want to rotate it around, then that means that, what angle is it? Okay, so let's have a look. Well, okay, so that angle there that's 90, that's 60, and that's 60. So that's the latest angle, the last angle of the triangle, and then they're opposite angles, so that has to be 60. So in other words, it's bouncing up at angle 60. So it's coming down here at V, say 1, and going back up at V2. And you have coefficient of restitution. So you have a little bit of collisions thrown in there. So how would you do that? Well, it's okay, we need to find the velocities as it lands. So those are just the normal equations. So it would be Vx and Vy. So that's they are, so Vx is Ux plus AT flight, and Uy, U subscript y plus a time of flight. So that would be Ux is, that's your horizontal one there, so it's U cos 30 minus, and your acceleration in the G direction, or sorry, in the I direction, is minus J sine 30, and it's minus J cos 30. Okay, so it's for X minus J sine 30 time of flight, U sine 30 minus J cos 30. It's always the opposite. So if that is cos, that's going to be sine, and time of flight. Time of flight you've got from the previous one, from the previous question. You'll have got the range D. So first of all, you would have had to get the time of flight. So you'll know that. So then you plug it in there and there, and you get your Vx and Vy. Then you're told, okay, so it goes vertically upwards, so you're told the coefficient of restitution is E. Now, important thing to remember again, of course, is that the coefficient, the collision and the restitution is only going to operate in the y direction. So it's Vy2 will be equal to minus E times Vy1, so that's important to remember, and Vx2 will just be equal to Vx. So that will be unaffected by the collision. Remember, the collision is always acting on just one plane. So it'll be this. So once you have your final Vy2 and Vx2, so you then now know that the angle is 60, so tan of 60 will be equal to Vy2 over Vx2. And tan of 60 is what? That's the, draw your 60 triangle. That's root 3, isn't it? And that's 1. So tan of 60 is root 3. So your minus E times Vy1 over Vx1, because that'll be unchanged, is equal to root 3. So E then will be root 3 times Vx1 over Vy1. And but you've calculated up there using T-flight, and it'll be minus there. So that, because the Vy will have changed direction, and that will give you E. So that's just the only thing to remember there. So a little bit of collisions, and sometimes that comes into projectiles, they'll throw it in. And another one they'll give you is if it lands horizontally, so it goes like that. So if it lands horizontally, then you know the velocity is horizontal. So if that's, say, you're 30 degrees, then that's also equal to 30 degrees. So if it lands horizontally, then you can use that to say tan of 30 is equal to Vy over Vx. So that gives you a relationship there, and an equation for Vy over Vx. So it's something that you know. So there's just a few possibilities that you get with projectiles.